Assalamualaikum brothers and sisters. So this is the video to show you the solutions for the examples chapter 5 part 2 BJT amplifier. So these examples will cover common emitter with RE, common emitter with bypass capacitor, and finally common collector. Okay, so the first one, okay, which is this example, is going to be about common emitter where there is emitter resistor. There is RE. Okay, so you can see the output is measured at the collector, right? Collector terminal. So the question asks, if your Vs here is 0.2 volt peak to peak, the output V out will be equivalent to, what is the value of the V out peak to peak? Basically, you need to multiply with the gain, right? So I think this answer should be minus 1.14 volt peak to peak. Why? Because the gain is a negative value, kan? Common emitter gain is negative value, right? So firstly, you have to do the DC analysis. So I'm going to do the DC analysis now. Okay. So you have to do the RTH, VTH. So RTH is equivalent to 56 multiply with 5.6 over berapa ya? 61.6. Okay, you will get 5.1 kilo ohm. Then VTH is equivalent to 5.6 over 61.6 multiply with the VCC is 15, right? Okay, VCC is 15. So 15, you will get is 1.364 volt, right? Your circuit will be simplified as follows. At the moment, this will not be connected to your DC analysis because coupling capacitor is open circuit during DC analysis. So at the moment, you just ignore the VS and the RL. So VBE on is given as 0.65, okay? And you're going to do the BE loop. So the BE loop equation will be IB RTH plus 0.65 plus IE RE minus VTH equivalent to 0, okay? And but IE equivalent to 1 plus beta IB, okay? The question gives beta 140, so means that 141 IB, okay? So put in the equation, you will get IB equivalent to 1.364 minus 0.65 over RTH plus 141 multiply with RE. RE is berapa? 0.68 kilo ohm. Okay, 0.68 kilo ohm. So you will get IB, okay, 7.07 microampere. Okay, but we want to find IC in order to find the parameters. Okay, IC equivalent to beta IB 140 multiply with 7.07 times 10 minus 3 milliampere. Okay, so you will get 0.9898 milliampere. Okay, so that is your IC. So you can find your R pi and GM. Your R naught is infinity because your VA is infinity. Okay, so that's why R naught infinity. We know that straight away. R pi is equivalent to beta VT over IC. So 140, 0.026 over 0.9898, and you will get 3.68 kilo ohm. Okay, right? And GM, the transconductance equivalent to IC over VT 0.9898 over 0.026, and you will get 38.07 milliampere per volt. Okay, so that's the AC parameters. Okay, so now you need to draw the AC equivalent. So this is your R pi GMVBE. Okay, this is base, emitter, collector. So I don't have to draw my R0 because R0 is infinity. Okay, so next is connecting your other parameters. So base connected to RTH, and this is my VTH off. Okay, then my C is connected to RC, and again this is my VCC off. Okay, and your E connected to RE, then to ground. Okay, so the output is measured at collector. Okay, so that's the AC equivalent, right? Your VBE is the voltage across your R pi. Okay, and this is your VI, right? So take note, VBE is always the voltage across R pi, and VI is the voltage from base to ground. Okay, so let's follow the steps in your common emitter. Okay, so the steps to obtain voltage amplifier component. So firstly, you get the equivalent resistance at the output side. So output side R0, you can see that at the output side you only have RC. Okay, you only have RC here. Okay, so R0 is RC. Okay, so R0 equivalent to RC, which is equivalent to berapa? 6.8, right? So 6.8. Okay, 6.8 kilo ohm. Okay, then V out equation is equivalent to minus GM VBE R0, which means that minus 258.876 VBE. Okay, right. So that's the V out equation. Next, the input side. So this is the uniqueness of common emitter with RE. You have to calculate what is RIB. Okay, so RIB is this equation. So what you're going to get is 3.68 plus 140, 0.68. You will get 99.56 kilo ohm. Okay, then Ri is equivalent to RIB parallel with RTH. So you will get 99.56 multiplied with 5.1. The RTH is 5.1 tadi. So 99.56 plus 5.1 is over 104.66 is 4.85 kilo ohm. Okay, so that's your Ri. And then this step, VI is equivalent to VBE multiplied with RIB over R pi. So you're going to get VI equivalent to VBE 99.56 over 3.68 is 27.05 VBE. Okay, now you're going to calculate the open circuit voltage gain. All right, so in order to do that, we know that AVOC VI equivalent to V out. Okay, so AVOC VI is 27.05 VBE, and V out from step number 2 minus 258.876 VBE. So you can cancel out VBE, and you're going to get AVOC equivalent to minus 9.57. Okay, so that's your AVOC, right? Now you're going to connect the voltage amplifier block that we have obtained. Okay, so this Ri, this is R0. Now only you're going to connect, okay, with the Vs and the RL. So this is the coupling capacitor that connects with the input signal. So just directly connect to Vs. Okay, and then the other CC, okay, which is connecting your RL, and this is 10 kilo ohm. Okay, so your V out is measured here, and this is my VI. Okay, and that is my AVOC lah. So this is my AVOC VI. So this time, AVOC VI is not equivalent to V out because there is load. Okay. Okay, so V out is equivalent to, we have to use voltage divider, RL plus R out multiply with AVOC VI. So you have 10 over 10 plus R naught. R naught is your RC just now. So 16.8. Okay, AVOC is minus 9.57. And your VI is equivalent to VS, right? Okay, because they are in parallel. So finally, you're going to get the gain V out over VS equivalent to minus 5.7. Okay, 5.7, that is the gain. So if my 0.2 multiply with minus 5.7, what will I get? 0.2 times 5.7 is 1 minus 1.14. Okay, so that's the answer. Okay, so that's how you solve the common emitter with RE. So this next example is common emitter with bypass capacitor. So how do you know that it has bypass capacitor? Because you can see that there is a capacitor connected to your emitter terminal ni. So that means this is your CE. Okay, and similarly with the first example just now, your voltage amplifier block will be connected to a load resistor. Okay, and this is coupling capacitor 1 and coupling capacitor number 2. Okay, so your voltage amplifier block will connect with VS and will connect with RL. That is the last stage of your calculation later. Okay, so this question asks you to draw the AC equivalent circuit, calculate the gain and the input resistance. Okay, so the good thing about this circuit, this kind of biasing is biasing by current source. That's what we call it, biasing using current source. So what you can see here is, all right, your emitter is biased with this current. Okay, you are providing IE with 0.2 milliampere, which means that IE is given 0.2 milliampere, which means that you can calculate IC straight away. IC is equivalent to alpha IE, right? Okay, and alpha you can calculate using beta, which means that 200 over 201 multiply with 0.2. So IC equivalent to 0.199 milliampere. Okay, so now you get your IC, you can calculate your R pi, GM, and R naught. Okay, so R pi is 26.13 kilo ohm. Okay, then GM is 7.65 milliampere per volt. Okay, and again R naught is infinity. Okay, because your VA is infinity. Right, so let's draw the AC equivalent. Okay, so again I have base, collector, and this is my emitter. So I have R pi, GM, VBE, and again there is no R naught. All right, R naught is infinity. So now let's connect the other parts. Okay, so we have again C connected with RC, and this is the power supply 5 volt. Okay, so this is 20 kilo ohm, and this is my 5 volt off, right? Okay, then straight to ground. Okay, my B is connected to 100 kilo ohm. Okay, so that's my 100 kilo ohm, right? And then this is grounded. Okay, now for the emitter, okay, it will be connected to the current source. right? Okay, so we know that voltage source, okay, DC voltage source, AC, short circuit. Okay, so for DC current source, it will be open circuit during AC. Okay, so for your current source, it will be open circuit. Okay, and then this voltage source will be short circuit lah. But what is the point? Because you have an open circuit already. So let's say if I continue to draw the minus 5 volt off, okay, and you have the ground here, but you have the what? The coupling capacitor, the CE here will be short circuit and it will provide the path to ground. Okay, so your current will go here, okay, but it cannot go to this path because it's open circuit. It will go through the short circuit path provided by CE. Alright, so eventually your AC circuit will look like this. So this is similar to common emitter type number 1, right? And the steps will be very simple. Don't forget to label your VBE. This is the voltage across R pi, and this is my VI. Okay, so obviously you can see straight away VI will be equivalent to VBE, right? So let's just follow the steps. So R not be equivalent to RC, which is 20 kilo ohm. All right. V out will be equivalent to minus 7.65 20 VBE, and you're going to get 7.65 times 20 minus 153 VBE. Okay, that's the output side. Input side, Ri equivalent to R pi parallel with the 100 kilo ohm. So I have, so 26.13 multiplied with 100 over 126.13, 20.72 kilo ohm. All right. And VBE in terms of VI, VBE equivalent to VI. Okay. So now let's get the open circuit voltage gain. Right. So AVOC VI equivalent to V out. Okay. So AVOC VI is VBE and V out is minus berapa tadi? 153. Okay, 153 VBE can cancel out. So AVOC is minus 153. Okay, that's my AVOC, right? So next we can connect the voltage amplifier block. Okay, RI, R out with the input signal. Okay, again you have the CC1 and this time you have a resistor and this is my input signal, and here you have the CC2 connected with your RL. Okay, so both sides you are going to do the voltage divider. Okay, so this is 20 and your R0 pun 20 kan. And your RI tadi kita dah dapat, and RI is 20.72 kilo ohm. Right. So let's do the calculation. So again, we know that AVOC VI is not equivalent to V out. Okay. There is load. Okay. So V out equivalent to RL plus R out AVOC VI. Okay. Which is 20 over 40 is 1 over 2. AV is minus 153, the AVOC, and VI is equivalent to 20.72 over 40.72 VS, right? So you can calculate V out over VS equivalent to minus 38.93. Okay, so what is the answer? Do I get the answer? Hey, Yes. So AV is approximately minus 39 and RI is 20.72. So that's what we get. All right. So that is common emitter with bypass capacitor. Okay. So the third example is common collector. Okay. So common collector configuration. You are asked to find the voltage gain, right? So this is a standard BJT configuration. But you can see the output is measured at RE. So that's how you know that you are dealing with common collector. Okay. So again, first thing you need to do is the DC analysis. Okay. So what is the RTH equivalent to 10 multiplied with 33, 43, what do you get? 7.67 kilo ohm. Okay. VTH equivalent to 10 over 43 multiplied with 12 is 2.79 volt. Okay. So if you do your DC analysis, okay, this is your VTH. Okay, and this is given as 0.7 volt. Do your KVL. So I have IBRTH plus 0.7 plus IERE minus VTH equivalent to 0. IE equivalent to 1 plus beta IB have 126 IB. Okay. IB is equivalent to 2.79 minus 0.7 over RTH plus 1 to 6 multiply with, what is my RE? 1 multiply with 1 kan, so tak ada masalah. So 2.09 over 133.67 equivalent to 0.0156 milliampere. So IC equivalent to 125 multiplied with 0.0156, 1.95 milliampere. Okay, so let's find your R pi, GM, and R naught. So those are the AC parameters. Okay, so let's do the AC equivalent. This time R naught, we have a value, so you have to put it in. So it's my collector, base, and it's my emitter. So let's connect the other parts. So you have RTH is my VTH off. Okay. And C is directly connected to VCC. It's my VCC off. Okay, ground. Okay, so E, it has RE and then straight to ground, and my V out is measured at the emitter terminal. So, as I mentioned in the video, you need to rearrange kan? Okay, so you need to rearrange the AC equivalent so that your output is on the right hand side. Okay, so what you need to do is, okay, I'll just show it over here. I just bring my RE to the right hand side. Okay, so this is my V out, my emitter to ground. Okay, and then so this is done. Okay, after that I need to take care of these other 3 branches. So let's start with R naught. R naught is between emitter and C. Okay, but because C is grounded, okay, this collector terminal directly to ground. So this is my ground kan? So there is no problem lah. I just bring it together. So this is my R naught. Okay, and then next branch is this guy and pointing towards E. So this is my E. So it has to be upward. and connected to C to ground. So that's why dia terus ke ground. And finally, this is between base and E. So I have to put my R pi horizontally, okay? And then you have your RTH, okay? And that will be your ground. So that's the equivalent for your common collector after you rearrange all the components, okay? So then you can do the steps. So I naught is here. Okay, for your V out, I have labeled your output voltage at your emitter terminal. Okay, so let's find R equivalent. So you can see, so the R equivalent, you can see I labeled as R equivalent because as I mentioned in the video, the output resistance of common collector, okay, as I mentioned in the video, you have to use a formula kan. So that's why I labeled this as R equivalent. Okay. So R equivalent is equivalent to R naught parallel with RE. So what will you get? So you should get 0.99 kilo ohm. Okay. And then I naught equivalent to VBE. GM is I naught is 75.6 VBE. So V out equivalent to 75.6 VBE multiplied with 0.99. So you have 74.844 VBE. Okay, so that's my V out. And you can see my V out is positive. Okay, why is it positive? Because it will go in this direction kan, and plus minus is the same as in the question. So that's why your V out is positive. Okay. Next is your RIB. So what I have here is 1.67 plus 126 multiplied with R equivalent, which is 0.99. So 126.41 kilo ohm. RI is equivalent to RIB parallel with RTH. So 126.41 multiply with 7.67 over 134.08. So 7.23 kilo ohm. Okay. So VI in terms of VBE, VI is equivalent to VBE plus V out is 74.844 VBE is 75.844 VBE. Okay. So finally, AVOC VI equivalent to V out. So AVOC equivalent to VI is 75.844 VBE. 74.844 VBE. You can cancel VBE out. And finally, your AVOC, you will get equivalent to 0.9868. Okay. Okay. So now you want to find the voltage gain. Okay. So AVOC VI is my R naught. Okay. But because there is no RL, it will be easier lah. You can see, you just need to short circuit the coupling capacitor, connect straight to the VS. Okay. So just CC, and then this is the VS. AVOC VI is equivalent to V out because there is no load. Okay. So and VI equivalent to VS 0.9868. VS equivalent to V out. So V out over VS is 0.9868. So that's the voltage gain. Okay. Which is the answer ke 9868, right? So approximately 0.987. Okay lah. Okay, so this final example is simple because you are just asked to find what is the DC collector current and what is the value of the output resistance R0 of the common collector. The first one is just the DC analysis. So DC analysis again, RTH equivalent to 60 times 40 over 100 is 24 kilo ohm. Okay. VTH is equivalent to 60 over 100 multiply with berapa? 10. Okay, so you should get 6 volt, right? Kan 1, 2, 3, 4, 6 volt. Okay, so the DC collector current can be calculated just using the BE loop like this. VBE on is 0.7. Okay, this is my RTH, VTH. Okay, so this is 5 kilo ohm. Just use the VE loop. IB RTH plus 0.7 plus IERE minus VTH equivalent to 0. Okay, so IB is equivalent to 6 minus 0.7 over RTH plus is beta given 100, beta is 100, so 101 multiply with 5. So this one, we know the answer, right? Just multiply this one equivalent to 1 plus beta IB. Okay, right, so you should get 5.3 over 515 0.0103 milliampere. So part IC equivalent to beta IB, so 100 0.0103 1.03 milliampere. Betul tak? 1 milliampere. Okay lah, almost kan? Okay, so that's the answer for the first part, right? And then the answer for R0 for common collector. Okay, so R0 is equivalent to R pi over 1 plus beta in parallel with RE in parallel with R0. Okay, so you can see that R0, the small R0, so VA is not given, so VA is infinity. Okay, so if VA is infinity means that you don't have to worry about R0. Okay, so you just need to calculate what is R pi. So R pi equivalent to beta VT over IC equivalent to 100 multiply with 0.026. So let me use the answer, which is 1 milliampere. So I will get 2.6 kilo ohm. Okay, and then R pi over 1 plus beta is 2.6 over 101, 0.0257 kilo ohm. Okay, so now I can do the R0 calculation. 0.0257 multiply with 5, 5 plus 0.0257 is, I get 0.0256, okay, kilo ohm. And if I convert to ohm, 1, 2, 3, I will get 25.6 ohm. Alright, so I think that's the answer, 25.6 kan? Yes, okay. But this is based on using IC 1 milliampere. So if you use IC 1.03, you will get a different answer. But of course, I will check your work. As long as the procedures are correct, you will get the marks. Okay. So that's it. That's the end for chapter 5. So I'll see you next week. Bye. Assalamualaikum. Madam Faraida signing out.